Thank you for watching today's review of equations and functions. Sometimes we get problems like this, lots of variables on both sides, and they ask us to go ahead and solve and tell whether this situation has, how many solutions it has. Well, if you'll notice here, if we start combining like terms, we get negative 11m plus 1 equals negative 11m, negative 3 plus 4 is positive 1. I already noticed that on both sides of the equation, I have the same thing. But let's say I didn't notice that and I continued and I said, well, I got to move my variables to one side. And I add 11m to both sides. I'm going to get 1 equals 1. Well, 1 does equal 1 and I have no variables left. Since 1 always equals 1, the answer is infinitely many solutions. If I had a problem, let's say, where when I solved it, my variables canceled out and I had, let's say, 0 equals 4 or 7 equals 2. Well, since that's not correct, 0 does not equal 4 or 7 does not equal 2, then I would have no solution. And let's say I had a problem and I solved this and I got what I'm used to, which is just m is equal to some number. Say m is equal to 4 or m is equal to 7. That would be an example of only one solution. But in this problem, when we solved it, we got 1 equals 1. So we have infinitely many solutions. Sometimes they ask us to write equations, and you can read this problem. What I tend to use is I tend to use a format called magic boxes. I show this to the students a lot. And I say, y is going to equal some number in this box. And to help me lay this out, I'm going to put my multiplication division in the first box and addition subtraction in the second. Call this magic boxes. So I end up getting a format magic boxes, which is obviously slope-intercept form. So she has 425 stamps in her collection. Since she has that, that's going to be addition and subtraction. She wants to collect at least 715 stamps. So since I notice these problems are multiple choice and they all have the totals over on this side, she wants to collect at least 715. That means 714 would not be enough. I need a number larger than 715. But since 715 would be enough, it could be greater than or equal to 715. And they want to write and solve an equation to show how many more stamps she must collect. Well, this one really isn't, if I think about it, I just need to collect more stamps one time. That would be a little invisible 1 in my multiplication box. I don't need that. And I call it magic boxes because if I now pull my boxes away, I can see that I have D plus 425 is greater than or equal to 715. I have two choices here. Notice that they wrote this in a different order than I did, but I can still figure out the answer. This is D and 425 added together. I'm going to be greater than or equal to 15. But that also says that the value of D would be greater than 715, but she doesn't need to collect 715 more stamps because she already has 425. So let's look at the other option. 425 plus D is greater than or equal to 715. And that says that she needs to collect more or equal to, amount more or equal to 290. Well, that seems to make some sense. Let's check that out. If we had 715 and we subtracted 425 from both sides, we do get 290. We'd model that or show you algebraically. We'd be doing that. And D would be greater than or equal to 290. It's always good to check this because let's say I also had a choice here that said E, none of the above. I want to check and make sure that math works. Okay, another question that gets kids a lot. What is a function And how do I write the domain and range of a function? So let's first start off what is a function. A function means that for every x value, you have one and only one y value. Simply meant you can't have x sometimes be a number and the same x sometimes be another number. Let's think about that mathematically. Let's say your x was 1. You can't have x, y, sometimes be 2, and sometimes be 3. Because think about it, mathematically, there's nothing you can do to 1 that if you do it, sometimes you'll get 2 and sometimes you'll get 3. Math is the type of thing that if you put a number into an equation, you're going to get the same answer every time. We tell the kids a good way to check this is called a vertical line test. Vertical line means I take a vertical line and I draw it through any point on a function, and I continue it down. Will I intersect another point? And in this problem, you see that yes, I do intersect this line, this point, and also this point on the same vertical line. So this fails my vertical function test. So let me draw another line. Let me draw a similar equation on the same graph that would be a vertical function. So I'm going to make a red V here. And to show that it ends, I'm going to put some endpoints on. And you have to bear with me here, as my drawing is not exact. But what I've attempted to do is have a line that does not go further on the x-axis as an x value than -4, and does not go higher up here than 5. Over on this side, this does not go further to the right on the x-axis than 3, and does not go higher on the y-axis than 3. So my domain, meaning my x values, are somewhere in between -4 and 3. And my range is somewhere in between 0 is the lowest I go. Put a dot there so you know that that's there. And the highest I go on y is 5. Now notice I put less than and equal to signs. If I had had, let's say on this one, an open circle, then that would have just been less than, but not equal to 3. It still didn't affect my y value, because over here you can say the y value went as high as 5. From the domain and range information, you could not graph from domain and range. For instance, I could have a function that looked like that. Let's say it goes as far on the x value to the left, -4, and as far, the highest value would be just less than 3. And over here, the range would be somewhere between 0 and as high as 5. So that's an example of some information, how you draw a, find the domain and range. Once again, this original black angled line is not a function. This red line is a function. And what I'm trying to show here, this black line is also a function, because I know it's hard to see here. What I'm trying to demonstrate is that it has no 2 points on the same vertical line. Usually the computer generated ones we give you on tests are a little bit easier to see that. Sometimes we give you an x and a y values and ask you to find the relationship and write an equation. Once again, we always want to start with slope-intercept form. And you'll remember that your change in y, which in this case y is going up by 1 every time, over your change in x, and here it's going up 1 every time, is your slope. So 1 over 1x, which would, in this case, just become x. Now you have to find your y-intercept. What I always say is, let's just see what would work if 1 times what is 6? Well, 1 times 1 is 1. What do I need to get to now from 1 to 6 after I've multiplied? I have to add 5. Let's see if that works. 1 times 2 plus 5 is 7. 3 plus 5 is 8. Sometimes the books also show you, since you have 1 here, you can work this pattern backwards. Since here you're going up by 1, if you go down by 1, x is 0. In this pattern, you were going up by 1. If you go down by 1, you would get to 5. Let me give you, because I don't know if how well that worked. So let me just give you another pattern. 1, 3, 5, 7, 9. And I'm going to call this 4, 8, 12, 16, 20. I think you get here that on this problem, my y value is increasing by 4 each time. My x value is increasing by 2. So 4 divided by 2 is 2, or y equals 2x. Now let's check this. Well, 1 times 2 is not 4. 1 times 2 is 2. I would have to add another 2 to get to 4. And 3 times 2 is not 8, it's 6, but if I add another 2, I get to 8. So I've written the equation for this other set of values that I've come up with. And the last one we had here is really a trick question. They ask you to solve this absolute value equation. Well, if I subtract 5 from both sides, negative 7x minus 4, well, since the absolute value of a number cannot be equal, cannot be negative, absolute value is always expressed as positive, there is no solution. If I changed this problem and I did the absolute value of 7x minus 4 minus 5 is equal to 4, then when I added 5 to both sides, I would get 9. So since the absolute value of 7x minus 4 equals 9, that means that 7x minus 4 could equal 9, or 7x minus 4 could equal negative 9. And when I do this problem, just going through this quickly, 7x equals 13, so on this one, x equals 13 over 7. Add 4 to both sides here. 7x equals negative 5, so x equals negative 5 over 7. So I hope this has helped out. It's a review of some of the first few chapters in the Algebra 1 book that you used last year, and gives you a little bit of an overview again on expression, on equations and functions.